Welcome to Python Geospatial Mapping. In this lesson, you will learn how to work with Python, explore real-world geospatial data, and visualize it using friendly tools. You do not need any programming experience, just curiosity. We will build up step by step, from basic variables to mapping airline passenger flows. Running the cell now. Ready? Let us get started. Let us keep our workspace neat. We are importing a module that handles system warnings. Then we tell it to ignore any warnings. This comment says we are stopping most warning messages. Sometimes, warnings appear during data analysis. This will help you focus on learning the basics without confusion. Running the cell now. What is geospatial data? Geospatial data means information that has locations or coordinates attached to it. Think of airline routes, city locations, or weather measurements. It helps us answer where questions using data. Running the cell now. Imagine all the questions you could ask with a map. Let us create our first variable. This comment tells us we are setting a variable. Here, we are creating a variable called city and giving it the value London. Print is a command that shows what our variable holds. Python stores words or sentences by using quote marks. This is called a string. Running the cell now. Try changing the city to somewhere you like. Numbers are important for things like counting or measuring. Here, we are showing that variables can also store numbers, like 250 passengers. We save the number in the passengers variable. By printing it, we check the value. Running the cell now. Numbers and text are the two main types we will use today. Sometimes, we want to keep track of several things. Lists are like a row of boxes that hold information together. We use square brackets to make a list called cities. Printing the list lets us see the contents grouped together. Running the cell now. Lists will help when we work with datasets soon. Let us see how to get a specific city from our list. Lists start counting at 0 in Python. If you want the second item, you use the number 1 in brackets. Running the cell now. Try changing the number inside the brackets. Real-world data. Now let us try working with real airline passenger data. We will use a CSV file, which is just a table of information, with months and the number of airline passengers. Then we will learn how to explore and plot it. Running the cell now. Let us see some real numbers. Let us bring in some real data using a special tool called Pandas. We label this step as our data setup step. This line loads a library, called Pandas, for handling tables. We have the web address for our data. It is a CSV file. We open the file and load its table into a variable called df. Now we look at how many rows and columns there are. We show the first few rows of our real dataset. Running the cell now. Do you see columns for passengers and months? That is airline data. Let us look at the data as a picture. Now, we create a chart so we can see how passengers change over time. This line brings in a tool for making charts and graphs. We make a line plot using the month for the x-axis and passengers for the y-axis. Titles help us understand the plot. We add a label, so we know the y-axis shows passengers. Finally, this line shows our chart. Running the cell now. Try spotting any patterns or peaks in the line. What was the busiest month recorded in our data? Let us find out. We want to find which row has the biggest value for passengers. This line looks for the biggest passenger number and returns the matching row. We print out the month when there were the most passengers. Running the cell now. Finding the top or bottom value is a common task with data. Let us turn the list of months into an easier format to work with. Now, we are making a plain list from the month column. This makes it easier to use in Python code. Here, we print just the first 5 months from the list, so it does not get too long. Running the cell now. You can use lists to loop over items or select a time window. Now, let us count how many months were above a passenger threshold. We are checking the table for months with more than 400 passengers. The code filters the data and keeps only those big months. We print how many times that happened by counting the rows. Running the cell now. Try different numbers like 300 or 500 as your threshold. Sometimes you want to check if a particular month is in the data. We prepare to handle a case where the month may be missing in the data. This line asks for a month from the user, such as 1950 to 2008. We now check if that month is found in our months list. If the month matches, we give a confirmation message. If not, we explain politely that it is not found. This is called safe access. We check before assuming data is there. Running the cell now. Try a month you see in the chart, or make up one to test. Let us label each month high or low based on passenger numbers. We are adding a new column to our table. If the passenger total is bigger than 400, we call that month high traffic, otherwise it is low. Here we print the change data, showing the traffic level labels. Running the cell now. Labeling helps us see patterns and group similar months. Now let us clean up by taking away a column we no longer need. Cleaning data sometimes means deleting columns we are done with. This code removes the traffic level column from our table. We show the first few rows to confirm the column is gone. Running the cell now. You can always make a column again if you want to use it later. Data tables often contain useful numbers we can summarize. We use some built-in functions to find patterns in our passenger numbers. Mean gives us the average, a typical value. Minute tells us the smallest value. Max gives us the biggest. These are called statistics. Running the cell now. These 3 metrics help you understand your data quickly. What if you want to see every date with very high traffic? This is a loop, which lets us look at each row in our data one by one. For each row, we check if the passenger count goes above 450. If so, we use print to display the special month. This makes it easy to spot high traffic periods. Running the cell now. Try finding months with different cutoff values. Let us quickly pull out months that were not as busy. We use a list to store all months with very few passengers. List comprehensions let us write this in a single line for speed and clarity. Printing lets us see if our logic worked. Running the cell now. List comprehensions save typing and are very useful for simple filtering. Sometimes, you want to sort your table to see top results right away. We create a new variable and fill it with our data in a new order. Sorting by the passengers column, highest first, lets us see the busiest times. We print the first rows to spot the top months. Running the cell now. Sorting is helpful for ranking, spotting records, or making leaderboards. Let us see how many passengers there were in recent years only. We use a Python tool to handle years, so we can select certain rows based on date. Here, we look for months that are after 1954. This gives us just the recent part of the table. We add those numbers together to get the total. Now, we print the grand total for these years. Running the cell now. Practice summing data for useful time periods. We are ready for a mini project. Let us make our plot more informative. This project charts the passenger numbers and shows year starts to spot seasonal jumps. We add a NumPy import for data math. Here, we make a big wide figure for better viewing. The blue line shows monthly airline traffic up and down. Red dots highlight the beginning of each year as reference points. We label the horizontal axis. We give a label to the vertical axis. This changes the labels on the axis to show only the start of each year. It also tilts them for easy reading. We show the legend so we know what each line and dot means. This is the chart title for context. These lines are just spacing so nothing is cut off. We display the final chart. Running the cell now. What trends do you see? Steady growth, dips, or rises? Try changing colors and run again. Now let us connect the idea of passenger traffic to actual city locations. Here we make a dictionary that gives coordinates for famous cities. We pick out the top for busiest months, one for each city. This line shows the month names that are busiest in our data. In a real map, we could plot each city by its numbers. Now, for each city, we print the location as latitude and longitude for a real-world feel. Running the cell now. Great job, you are now mapping data to places. Which city would you add? A quick checkup helps prevent surprises. Good programming means looking for empty or missing data before you analyze. This tells us if any part of our table has missing values. Here, we show the type of each column, for instance, numbers or words. Running the cell now. Checking for problems early saves time in bigger projects. What happens when you try something that is not in your data? Even experts make mistakes. Let us see how Python reacts to them. We use a try block to attempt a risky action. This line asks for a column that is not part of the data. If there is a problem, the except part catches it and shows a friendly message. This is called error handling and makes code safer. Running the cell now. Try renaming columns in the code and see what happens. There are fast tools to summarize your data before a deep dive. We can get a summary of our whole table, including types and size, using the info function. Describe gives us numbers like average, smallest, and biggest for number columns. Running the cell now. Try these before starting a new project for a quick health check. Let us do a challenge. Can you find the first extra quiet month? This loop searches each row for a month with fewer than 150 passengers. Printing stops as soon as we find the answer using the break keyword. This is a real-world searching pattern. Running the cell now. Can you adjust the number to find different answers? Challenge yourself. Let us review our big steps today. Recap. What have you learned? You loaded real geospatial data, explored lists and tables, made charts, filtered and mapped real numbers to real locations. You built mini projects and learned to troubleshoot along the way. Keep building, and you will soon be a data explorer. Running the cell now. Thank you, and next steps. If you enjoyed this lesson, like and subscribe for more beginner Python projects on this channel. Try out the bonus challenge, pick a new city or dataset and make your own plots. See you in the next video. Running the cell now. Share your results or questions below. Keep learning.